Welcome to the Funtastic Academy. Hello everyone, welcome to the Funtastic Academy with me, Ayush Prasad. Today we are going to learn about the machine that makes the world go round. Literally. I'm talking, of course, about the humble electric motor and its cousin, the generator. But how do these work? And why are they so important? Learn all that and more in today's episode of the Funtastic Academy. But first, let's answer last episode's quiz question. What was the first ever science museum in India? The answer is the Birla Industrial and Technological Museum, which was founded in Kolkata by, of course, the Birlas. Now that that's out of the way, we can dive right in. Now, what does a motor do? That question's quite simple. It turns electric current into rotation. In this case, it's DC current, so it's a DC motor. But the real question is, how does it work? Now, a motor has three main parts. The first part is the stator. These are large, usually permanent magnets, and they always stay in the same place. The second part is a rotor. This part is the one that needs a current, and it's an electromagnet. So, currently, the current is from here, it's flowing into the magnet and making this side north. From here, it's making this side south, the ground current. So, the north side is attracted to the south stator, and the south side is attracted to the north stator. And this causes the rotor to spin, causing spinning. Thank you. Explanation done. But wait. Once I've spun from this to this, then what? The north end is with the south end, so it doesn't want to budge. Same with the south end. So what do we do? Well, that's where the third part comes in. The commutator. The commutator works by using this large metal ring where one end of both holes is attached to the electromagnet. There are these brushes which connect the flow to the commutator. When this spins and goes to this direction, this end of the commutator also spins, so it makes contact with this brush. And this end of the commutator makes contact with this brush. What that does is flips the direction of current. So now we have the same scenario as before. The north end is here, it wants to get to the south end, and we get repeated spinning motion. Now we can make various upgrades to this. For instance, if the brush is between the two wings of the commutator, it might get stuck. The solution to make it smoother is to add many tiny commutator rings to both increase efficiency and make rotation smoother. Also, to increase the power, you need to add many coils of wire along the rotor. We've depicted it as a simple bar, but it's actually a long T-shaped thing called an armature, and adding more coils around the armature gives more power. That's why in cutaway diagrams of these motors, you'll often see huge amounts of wires. They are extra wires which are going to the armature. Now, we've talked about motors, but I mentioned before they had a secret little cousin, the generator. It's the exact same thing, but in reverse. You start spinning a rotor and the energy gets passed down the wire. And there you have electric current. Now, motors and generators both help the world go round. How? transportation. How does a ship move? At the back, it has a screw, which is, you guessed it, a very large screw. It turns with a large force, which pushes a ton of water at the back and pushes the ship forward. But how does a screw get its power? Well, in most ships it comes from diesel, but not in the way you would expect. See, when the diesel is burnt, it turns a turbine, and the energy from this turbine is converted into electrical energy by the generator. Then it's converted into rotational energy by the motor, and this rotational energy is what pushes the screw. A similar thing happens in hybrid cars. A hybrid car can use petrol, but when it accelerates or decelerates, the energy in the battery can be charged or discharged, helping the car save energy by using electricity. Now, a generator is used to generate all power in the world. How? Well, think about every power source. Hydroelectric. Water goes down a dam. This turns a turbine which drives a generator, generating power. Geothermal. Water is heated by the heat of Earth's core. This creates steam which is used to turn a turbine which generates power. Let's do 4 in 1 now. Coal, oil, natural gas, nuclear power. All these sources of energy generate heat which boils water, generating steam which turns a turbine which generates power using a generator. You get the idea. Generators literally power our entire civilization. Think about it. What would our life be without electricity? Well, you couldn't watch this video, but there would probably be more pressing concerns like not being able to see in the night time, or not having a constant source of power to drive anything, to do anything. So, now we know how motors and generators help turn the world around. But the quiz question, what is turning? When you turn stuff, you get a certain type of force. But what's the name of that force? Tell me the answer. I'll see you on the next episode.